Welcome to Rosny College Electronics series of videos. This video I'm going to be looking at using the digital multimeter. So the multimeter is as the name suggests, a multi-function device that can measure each of the three quantities that we're interested in. So we've got voltage, we've got resistance, and we've got current. This particular one can also measure up to 10 amps maximum DC. Can also measure up to 500 volts AC, and it has a transistor testing station and a diode testing station. This we won't be looking at either the high current or the AC or the transistor testing, simply looking at voltage, resistance and current. Firstly, we're going to start with a circuit diagram. So we've got a simple circuit here. A 9-volt circuit, 9-volt battery connected in series with a 470 ohm resistor, a 220 ohm resistor, and a light emitting diode or LED. So here is the circuit that I've already built, and we can see that it works when I connect the battery. Okay, so there is my 470 ohm resistor, there's my 220 ohm resistor, LED, bit of breadboard wire connecting it to 0. So what we're going to look at, firstly I'm going to measure the voltage. I'm going to measure the voltage across the battery to start with. Okay, and I would expect it to be somewhat in the order of about 9 volts. Okay, so I'm going to turn the dial to the 20 volt reading because I don't expect that the voltage will exceed 20 volts, but it will exceed 2000 millivolts, which is 2 volts. So if I were to put it to 2000 millivolts and I connected it up to 9 volts, it wouldn't damage the multimeter, but I would not be able to read it at all. It would just say too much. Okay, let's show what it would read if I was to connect it. So this is in millivolts, so it's picking up all the random bits of noise and stuff as well. And if I go across, I've shown there, that means that it's exceeded the voltage rating of that level. So if I were to put it onto 20, so this battery is 8.44 volts, which is about right for a 9-volt battery when it's sort of on the way out. It's not fully charged, but it's still got a fair bit of life left in it. If I were to have it on the 200 volt reading, I would still see that it's got a voltage, 8.4, but notice how the decimal point now is moved to the right. We lose a little bit of accuracy, so I know it's greater than 8.4 and less than 8.5, but how much? So I don't really know. And likewise with the 500, probably just tell me 8 volts, let's see. Yep, this says 8 volts, which might be okay, but for our purposes we want to have it as accurate as we possibly can without exceeding the voltage range. So it seems to have lost a little bit somewhere along the way. Okay, so I've measured the voltage across my battery and it's 8.35 volts. Okay, so if I were to then measure the voltage across each of the components, so I'm going to measure the voltage across, so I'll just record this, so we've got 8.35. I'm going to measure the voltage across the 470 ohm resistor. So I'm connecting it this way, and with my black on the top and red on the bottom, and notice how it's got a negative. Okay, I could ignore the sign if I know I've done that. So 4.25 volts is across my 470 ohm resistor. Do the same across the 220, 2 volts exactly, 2.00. And I'm going to do the third one across the LED, 2.02. Okay, so we can now see that we've got 8.35 volts across the battery 4.25 volts across that 470 ohm resistor, 2 volts across the 220 and 2.02 across the LED. And that kind of makes sense because if you add them all together, well, that is very nearly 8.35. So the series voltages across here add up to the battery voltage. A small amount of error. So measuring voltages, very straightforward. Okay. Now I'm going to measure the current. Now the current is on this stage down here. Now I'm not really sure what I'm going to get. So I'm going to start with the largest. Well, that's the 10 amp one, I don't want that. This is the 200 milliamps. So this thing won't measure any higher than 200 milliamps. If I go over that, it'll just give a 1. Now, you've got to be very careful when measuring current with one of these. I cannot just put the probe straight across the terminals of the battery because internally it's nearly just a piece of wire, and all of the current going from the battery will go through that piece of wire, and well, it'll blow the fuse inside the multimeter. So in order to measure current, we actually have to have the current going through our meter here. So in order to do that, we need to break the circuit. So what I'm going to do is I'm going to remove this bit of wire. We'll place it down here to somewhere else. Okay, so you can see now my LED is not lit up, but I'm going to now connect my meter back into the circuit. So now my meter is part of the circuit. And you can see it's registering 9.1, and that's milliamps. So we've got 9.1 milliamps in our circuit, or 9.0. Yeah. So I can probably get a bit more accurate than that. So rather than 200 milliamps being the maximum, 20 milliamps is the maximum. I can't go to 2000 microamps because that's 2 milliamps. 2 milliamps is clearly less than 9 milliamps, so this would saturate. So if I do that, 9.05, so we've got just another digit of accuracy there. I'll show you what happens when you put it on too low. You just get that 1 again. Okay, so it doesn't give me a reading. It still works, like it's still part of the circuit. Hasn't damaged the meter, but I can't get a reading. So we've got 9.01 milliamps. Now to measure the resistance of a component, I have to remove it entirely from the remaining circuit. So I'm going to measure the resistance of the 470 ohm resistor. So I'm going to keep it in the breadboard and just unconnect the other components. So I've unclipped the battery clip, and I've unclipped or removed the other resistor that was connecting it. And I'm expecting it to be 470 ohms. So 2000 is the next largest number, and if I connect it across, we see that we're getting 464 ohms. So 464 ohms there. So it's not exactly 470, but I would not expect it to be, because like all things, the accuracy that these things are made depends on the machining and various other things when they make the resistors, and it's very, very difficult to get them accurate beyond a certain degree. Okay, so one of the tricks that I use is these have, the probes that we have very sharp tips on them, and I find it very easy to make a solid connection if you take the probe. I'll zoom in on that so you can see what I mean. Take the probe and stick it right in the same breadboard hole as the lead of your component is going into. So I do the same. All the way. I'll do the same with the other one. I'll stick it in there. Now you can see I've got a very good solid connection. I'm pushing down against the bench so it doesn't slide around. I could try and do it by holding it against the lead of the resistor, But as you can see, that lead just bends and moves, and if I look away, it's very difficult to sort of keep it there without focusing a lot on it, concentrating on it. So in the hole, much easier, and it won't slip around. Next video we'll look at how we can use some of these values I've looked at here to do some calculations.